Great God. You're all welcome to my tutorial, Meatballs tutorial. This is my handle at Meatball tutorial. And our hashtag, you don't need to be a scholar to get an A in mathematics. Now, welcome to our topic, set theory. So set theory part 1. Now, let's dive right into our class. Set. Well-defined object. Okay, a set is a collection of well-defined objects such as collection of tools in a mechanic workshop, collection of mathematical instruments, and so on and so forth. Example, if I have A equals to, let's say, collection of mathematical instruments, we have eraser, we have pencil, we have cleaner, and so on and so forth, then I close it, right? So this is an example of a set A. Is that okay? Containing mathematical instruments. Now, element of a set. Each member of a set that belongs to the set is called an element of that set. So eraser is an element of set A. Pencil, cleaner also is an element of set A. Eraser and cleaner are also the same thing. Let's continue. When an element X belongs to set X, we write it as X is a member of X. You see, this small e here signifies belongs to or is a member. So I can say eraser is a member of set A, right? I can also write pencil is a member of set A. So that's basically what all this is saying. Is that okay? Let's move on to our next slide. Okay, proper subsets. Now let's read. Consider two given sets A and B. If the set A consists of some or all the elements of set B, then A is said to be a subset of B. If I have my A to be equals to, let's assume my A is equals to 1, 2, 3. Then I have my B to be equals to, let's assume my B is equals to 1, 2, 3, 4, 5. Now you see A is a subset of B. Why is A a subset of B? Because A has, okay, A has elements of B which are 1, 2, and 3. So we can derive the elements of A from B. Therefore, A is a subset of B. Is that okay? Now we denote the set notation as this. A is a subset of B, which means and so on and so forth. If the set A is a subset of B with at least one member in the set B which is not in A, then the set A is called a proper subset of B. What does that mean? It means that if you look at this, the elements of A are 1, 2, 3, the elements of B are 1, 2, 3, 4, 5. So there is at least, in fact, yeah, not even at least, there are two elements which are not in A. Once there is at least one single element that is in B but not in A can be referred to as the proper subset of B. Is that okay? Yes. Okay. Now, when A is a proper subset of B, it is written as A is a proper subset of B. But when A is just a subset of B, you just put this dash that looks like equal to. So A is a subset of B. If it is not a set of B, or rather if it is a proper subset, there won't be that dash beneath it. Is that okay? Okay. Let's continue. So B is considered a superset. Now the set notation for superset is this. So in this case, this set notation signifies that B is a superset of A. Is that okay? Now the symbol this, which is referred to as braces, denotes set. So set is contained, or rather the members of a set are contained in what we call braces. Now let's look at common set notations. Now when you have a U of this form, something like that looks like U, it is called union. When the U is inverted, it is called intersection, and this is called our universal set. This, of course, what we discussed the last time, it signifies belongs to or is an element. So I can say A is an element of set A. Is that okay? Yes, why this means A is not an element of set A. Is that okay? Of course, this is a proper subset. This is a normal subset. Is that okay? This is not a proper subset, and this is not a normal subset. Now, this A with something here, we can call, let's say, A raised to the power of 1. It signifies complement of A. So we can either write it as A raised to the power of 1 or A raised to the power of C, anyone you prefer. Now, you see, this is called a null set. It can be referred to as a null set, a void set, or an empty set. So you can either write it like this or write it like this. Is that okay? Why you see something like n into bracket A means the number of elements that set A has. Is that okay? It can also be called the cardinality of set A. And you see, PA here refers to the power set of A. We are going to solve questions on everything. Why the one beneath it represent the symmetric difference. Now let's solve some questions. Look at these first beautiful questions. It says the universal set is defined as mu equals to. Now you see, our universal is equal to our x, and our x takes values from 2 to 10. Why is it 2 to 10? Because we have less than equal to, we have less than equal to. So x is equals to 2 to what? To 10. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10 as the members, or rather the element of our universal set. Now you see, its subsets are A, B, and C. So A, B, and C are the subsets of the universal, right? They are the subsets of the universal, meaning their elements are gotten from what? From the universal. Now look at A. A elements are defined as what? As even numbers, meaning even numbers from the universal, right? So we have 2, 4, 6, 8, 10. Even numbers, 2, 4, 6, 8 are number 10, something like that. Why prime numbers? Prime numbers are numbers that have 2 factors, itself and 1. And if we pick those numbers from this universal, we have it to be 2, 3, 5, 7. Now you see, C refers to odd numbers, and odd numbers from our universal are what? 3, 5, 7, 9. Now, you see the first question here says we should find our what? Okay, the first question says write down the set of A, B, and C, which we've done. The second says we should find our A complement. So our A complement refers to those elements in the universal but not in set A. Is that okay? Elements in set A are 2, 4, 6, 8, 10. Now, let's look for the elements that are in the universal but not in set A. We can see one of them is 3, 5, and 7. So 3, 5, and 7 are the elements which are in the universal but not in our set A. Is that understood? So that is the definition of complement. Complement means elements in the universal but not in that set. Now look at B also. So we can either write our complement to be A raised to the power of 1 or B raised to the power of, so anyone you want. Now our B complements are elements in the universal but not in set B. Now look at set B, we have 2, 3, 5, 7, but in the complement you see we have 4, 6, 8, 9, 10 elements in the universal but not in our set B. Now, B complement union C complement. Okay, before we solve this, we found our B complement. Let's find C complement. C complement, in the same way, refers to elements in the universal but not in our C. Now, look at our C has element of 3, 5, 7, 9. So the first element, which is in the universal but not in C, is 2, 4. The next one is 4. I have 6, we also have 8, then we have 10. So these are the elements in the universal but not in set C. Now, union means finding or joining the members of set B complement and set C complement. That means joining the members of 2 or more sets. Is that okay? Now look at what do we have here? We have 2 here, we bring 2 here, we have 4. You see, we have 4 here, we have 4 here. We pick one and we put it in our answer. We have 6, we have 2, 6, we have 6 here, we also have 6 here. You pick 1, 6 and you write. We have 8, we have 8, you pick 1, 8 and you write. We have 9, we don't have 9 here, but you also write it here because we are joining their elements. Is that okay? We have 10, we pick 1, 10. So we've solved this question, which says B complement union C complement. Without wasting time, let's go to our next question. I'm sure you understand this question. Now, our next question says, given that the universal set is defined as mu equals to y, that means mu is defined as y, and y has values from 10. You see, when you have less than equal to is telling you that our y starts from 10. But if there is no equal to there, it is telling you that it doesn't start from 10, it starts from 11. But since we have equal to there, it means y has values starting from 10. And you can see we have y less than 31 here. Y less than 31, you see there is no equal to here, telling you that y 31 is not a value of y. Instead, y stops at 30 because y is less than 31. Do you understand? Y has values from 10. Why is it 10? Because of the equal to beneath the less than. And y has values that stops at what? At 30, because y is not equal to 31 according to our definition here. Now, okay, so and that's why we have the members of our universal to be 10 to 30. Okay, now this universal has subset A, B, and C, and they are defined as follows. Now, because they are subset, their values must be gotten from the universal, right? Of course, yes. Now, A is equal to what? To prime numbers. So prime numbers from this universal are what? Remember, we said prime numbers are numbers that have 2 factors, itself and 1. So 11 is a prime number, 13, 15 is not a prime number, 17 is a prime number, 19 is a prime number, 23 is a prime number. Okay, so I think we've written everything here. So 11, 13, 17, 19, 23, and 29. All these are what? Are prime numbers. Now B is defined as multiple of 5. So multiple of 5. Multiples of 5 means those things 5 can go into without remainder. And we are, of course, is 10, 15, 20, 25, 30. C is defined as factors of 60. So all these elements here are the factors of 60. Are those numbers that can go into 60 without remainder. Now D is equal to even numbers. Now even numbers from 10 to 30 are written as the elements of D. Now it says, note, the cardinal number of elements means the number of elements in a given set. So if we are asked, find the cardinality of A, you write it in this form, N, and then you write your braces A, then you count. How many elements do we have in A? We have 1, 2, 3, 4, 5, 6. So that's why we have 6 here, because we have 6 elements in A. Cardinality of B means how many elements in B? Let's count. 1, 2, 3, 4, 5. So we have 5, and so on and so forth. So that is basically what cardinality means, or cardinal number of a set. Is that okay? I'm sure we understand this example. Let's go on to our next example. Okay, our next example says if mu equals to x defined as, now this x is defined as x is a member. You remember this E means belongs to. X belongs to or is a member of N. N, capital N in mathematics, is capital N means natural number. Is that okay? Capital N means natural number. So it is telling that X belongs to the group of natural numbers, and X will have a value. If you look at this, X has a value. You can see there is no equal to here. So because there is no equal to here, X doesn't start from -2. Instead, it starts from -1. And you see there's no equal to here also, so it stops at 10. So X has values ranging from -1 to 10, and that's why we have the values of our universal to be this. Is that okay? Okay. Now look at this A. A are subsets. Okay, A is a subset of our universal, which, okay, X is also belongs to natural numbers. and x in this case has a value from 3 to 8. You see, we can see our equal to here, equal to here, meaning x has values from 3 to 8, and that's why we have 3, 4, 5, 6, 7. 7. Okay, this is a mistake. I don't think there's supposed to be equal to here, so let's cancel it. There's no equal to here. Okay, let's continue. So we have b has values from -1 to what, to 5, right? So we have -1, 0, 1, 2, 3, 4. You see, it's not stopping at 5 because there is no equal to here. Now we have c having values from what? From, in this case we have 3, there's no equal to, so we start from 4. So we have 4, x has values from 4 to what? To 8. So we have 4, 5, 6, 7, 8 as the values of our c. Is that okay? Now let's go on to our questions. Our question, the first question says find a, b, and c, which you've done. The second question says find a intersection b. Now we talked about union in the last examples. In this one we are looking at intersection. Intersection means the common element between set A and B. Now look at set A, look at set B. What are those that are common? You see, 3 is common and 4 is common. So A intersection B is what? Is 3 and 4. Is that okay? Finish. That's all. Yes. Now you see the third question says we should find our A complement intersection B complement. To do that, we have to find our A complement first. And we said A complements are those elements in the universal but not in our set A. So if you look at this set, you can see that all the elements here are not in the set A, but they are from the what? They are in the universal. Is that okay? Same with our B. Our B, all the elements here are in the set, are in the universal set, but not in set B. Now, finding the intersection. Finding intersection meaning finding those things that are common. What are those things common? You see, 8 is common, 9 and 10. So A complement intersection B complement is 8, 9, 10. Now, A complement union C. A complement, we know our A complement. Okay, let's make our work neat. A complement is this. Now, our C is this. So, union means joining all the elements together. So, we have -1, 0, 1, 2. There's 4 here, so we put 4. There's 5 here, we put 5, we put 6, we put 7. Then there's 8 here, there's also 8 here. We pick 1 and we put 8. Then here we have 9, we have 10. So you see, we just joined all the members of A complement and all the members of C complement. Is that okay? And also A union B means joining the elements of A and B together. You see, these are the elements of A, these are the elements of B. Joining them together gives us -1, 0, 1, 2, 3, 4, 5, 6, and 7. Is that okay? I'm sure you all understood these questions. Any question you guys may have, you can either chat me up or write them down in the comments. Yes, thank you. So let's move on to our next example before we come to the end of this class. Now look at this fourth example. It says if V equals to A and B, that means the element of our set V is what? Is A and B. Determine the power of V. You see, when we have something like PV, it means the power of V. Now you see, that's the power of set V. And find also NPV, that means the cardinality of the power of our set B. Now the power of a set means all possible subsets from that set. All possible subsets from that set. And the first possible subset of V equals AB is what? Is a null set. A set without a value. So it's a null set or an empty set. Another subset could be A. So we have null set, we have A, we have B, and we have A, B. Is that okay? Same thing if I have another set to be equals to A equals to, let's assume 1, 2, 3. And someone asks you to find the power of set A. The power of set A will be given as, the first thing you have to do is to write your null set. So we can write our null set like this, right? You can either write it like this or you write it like this, anyone you want. Then our first set will be 1. Then we have 2. We have 3. Yes. These are all possible subsets. We have 1, 2. We have 1, 3. Okay. We have 2, 3. Yes. And then we have 1, 2, 3. So I think this is the answer to the power of A. So these are all the possible subsets you can get from set A, which is 1, 2, 3. Is that okay? Another way you can find the power of a set. Okay. I think that's all on power. Now let's look at the cardinality. To find the cardinality of the power of a set, okay, just count 1, 2, 3, 4. That's the number of elements in that set. Another way you can do it, you can use a formula 2 raised to the power of b, or 2 raised to the power of anything you want. Okay, now this b, 2 raised to the power of b, signifies the number of elements in the actual set. So you can see in this set V, the number of elements is 2. So our B in this case is equals to what? Is equals to 2. So if we have 2 raised to the power of 2, 2 raised to the power of 2 is equals to what? Is equals to 4. And this is exactly the same 4 we got here. Is that okay? Yes, that's the short form to find the cardinality of the power of a set. Now look at this example we did below here. To find the cardinality of the power of set A here, instead of counting, what do? We just do 2 raised to the power of b, right? And what is b in this case? B is the number of elements in set A, which is 1, 2, 3, right? So in this case, our b is equals to 3. So we have what? 2 raised to the power of 3. And 2 raised to the power of 3 is 2 times 2 times 2, which is equals to 8. So the cardinality of the power of set A is equals to 8. Let's count these are sets. These are elements here to confirm. Let's go. 1, 2, 3, 4, 5, 6, 7, 8. Do you see we are correct? So that's the short form to find the cardinality of the power of a set. So I hope I have impacted you to some extent on set theory. In our next class, which is our part 2 of set theory, we are going to be solving more examples under sets. So make sure you watch the video, you subscribe to our channel to get the video, and in this video make sure you like and you comment. Thank you for watching. Thank you for listening. May God bless you in Jesus' name.